on, it's saying preparing a live stream. And we are live.
Awesome. Thank you, Deepika.
Yes, and videos. When you think about what is the most important computer vision model, what comes to mind is objective.
Okay, I had another window ready, which is also me. Hello, everyone. I'm Sudha Jamthe, and this is WeeklyWed. And for those of you who are our regulars, we are not doing this every week. We are doing it every other week. And I'm combining with Sudha Live in the middle of the month. And 2 weeks out, I have a fun conversation with an expert. And this week's theme has been about Edge AI. And today's topic is going to be Edge AI with mobile vision. And I've been talking to you about vision and about various types of computer vision and IoT for many, many years. So I'm very happy to see some of my IoT friends around here. And in fact, I see in our Zoom room here, we have Rob Van Kranenberg, who is the founder of IoT Council and who started the IoT Day. And we do that once a year right here on April 9th. Okay. And so we are streaming this on YouTube just so that we can have a copy. So for those of you who miss it, we'll be able to come and watch it later. And LM from my team actually makes nice little clips and posts it on my learner community at Business School of AI. Other than that, it's going to be a nice closed room conversation with those of you who are present here. Since we are recording, if you do not want to be in the recording, I have no ways to edit it back. So I would appreciate if you don't show up on camera and use the chat window if you don't want to be in the recording. Otherwise, it's awesome. You're welcome to, speak up when we do the Q&A. Okay. So when I talk about Edge AI, I want everyone here to answer on the chat. What is Edge AI? Do you know what is Edge AI? Okay, to make it easy, is it AI built on the edge or is it AI running inference on the edge? Let me look at the chat window. And I think inference on the edge. Oh, Yash, I'm so glad you're here. Okay, so that's perfect because, we have a mixed set of people who are, familiar with edge. We're building AI on the edge. And the beauty of, so let me give you a nice video that Yash made just last night explaining Edge AI. It was quite a surprise for me. I'm going to share my window. It was quite a surprise for me. This is Yashashwini. She is one of my students from my responsible AI world, and she's actually taught courses with me at Barcelona Technology School about fairness and AI ethics. And she quickly put a video as soon as I told her that my recent Edge AI course has dropped and we're talking about Edge AI today.
Hi, good morning. So today here I am to tell you about a very important AI concept called Edge AI. Did you know that most of the processing of AI happens in the cloud, happens in the TPUs, and you will get the result. But what if AI could run on your edge device, that is your sensor or camera or that node which is at the end of the network itself? So that's Edge AI. Today, I want you to think about all those devices around you where Edge AI can function and see how Edge AI can be applied to your use cases. And not to forget, Sudha has come out with a new course on Edge AI.
Okay.
So Sudha Jamthe is a technology future.
Okay, I'm going to stop here. Love you, Yash. That's awesome. Okay, so I see the answers here. More people saying inference and running on the edge. So what's your favorite edge device? for those of you who are in the Internet of Things world, we know the jargons and terminologies, but you could be somebody working in enterprise, you could be in mining, in farming, in building applications for, various different customers. So, or you could have a home device, right? Phone, who said that? Minia, thank you for that. Actually, our phone has so many more sensors. Ida, thank you, Ida. So we have many sensors on the phone. In fact, today is exciting for me because we have a speaker who's coming back, and we are very grateful that he found time to come back and talk to us before the holidays. And the last time, so that is Karsten Konigstein, and I'm going to officially introduce him in a minute. But the last time Karsten was here, he actually showed us an amazing innovation that he had done using an Android phone. So he basically said the phone actually has so many sensors and it can track vibrations. So the last time when he was here, and we've been doing this WeeklyWed with expert speakers and discussion for 6-7 years, I believe. And so all of those are in our YouTube. And so every time we talk about something, we remember, this past session, and it's a full playlist if you want to go check it out. And I will ask LM to see whether we can locate that and share that on Business School of AI on LinkedIn. So what Carson did was he basically said, hey, what if there are old devices, old equipments in factories, and they cannot be digitized like newer devices or newer equipments and instruments? So how do we give it life and give it connectivity to make it an Internet of Thing, to just check the life of the equipment? So simple thing is you could check for the vibration of factory equipment while it is.
Hij staat uit hoor.
Yes, hi. So it will check for the vibration. What if it can check for the vibration of an equipment in the factory? And based on tracking the vibration, we can say, is this a normative wave of the vibration, or is it, going to, die? Is the machine going to have a maintenance issue? And to use AI to make that prediction. So Carsten did that. I got very excited. So while we were doing this, I took my phone, put it on my fridge, because that's the big equipment in my house right now. And so I put it on the fridge, and then it produced live vibration, and we could capture that in Carsten's app. So I'm super excited because now the same innovative team that was doing that with audio has, switched their focus to vision and said, hey, how can computer vision help us with Edge AI? And that is what Carsten is going to show us today. And, he works with a lot of clients. So I don't believe they will allow him to take videos from factories. And so he's going to show us a recorded session that he has from a demo. And then he's going to teach us what this whole Edge AI with vision and how you can do optimization in factories. Okay. Before we move forward, I have one question. When we talk about computer vision is the AI that is using cameras or images or videos. It's trained using images or videos, and it is typically from cameras. So can you think of a camera device that's an edge device? Again, you can write. I see Yash said wearables as our favorite IoT. Can you think of a camera device? Phone is not allowed because we already covered the phone. What else have we got? Do you have a device which has a camera other than a phone? So, okay, I see some answers coming. Security cameras. Ha, you're cheating, Rob, by saying not phone. Now Rob is saying my computer. That's true. That's true. We've had cameras on our computers for a very long time. And the camera on the computer is helping me, do Zoom and talk to you guys. Okay. I see car camera, robots. Yes. Robots, drones, autonomous vehicles, or even regular cars these days have so many sensors and they have cameras. Refrigerator. Adam, welcome back. So my fridge doesn't have a camera. You must have a very fancy fridge out there. So these days cameras have become very, very common. So and it's also relatively cheap. So you have that. So it could be a mobility device like a car or a robot or drone, and they all have their cameras by which they are watching anything that they need to. So that of course the cars and robots use that for mobility to find out what is in front of them or the environment. And then there are cameras attached to drones and stuff, or like a robotic arm. The other one of my favorite one is robo dog. Thank you, Yash. One of the other very utilitarian one is a robotic arm that is used in factories, or a surgical arm. And the surgical arm purely looks at everything using cameras. And then we have a lot of medical equipments that have like tiny cameras that are inserted into the body to go look at, things. And there's a whole bunch of things you can do with that once you get the data. Digital photo cameras, that's true. That's a very good one. Okay, I don't know if I'm missing anything. So the way I think about IoT and edge devices is start from your body, right? So you could wear a Fitbit, you could wear, I've switched out of cameras, I'm just talking about general IoT. You could, as an edge device. So it could be a camera, or it could be a Fitbit, it could be things you're wearing, it could be, you have, sensors on clothing, on shoes. I have a bunch of, favorite IoT sensors on my garments, on my shoes. In fact, I shared recently that Nike had come up with an IoT in their camera, in their phones. I mean, not phones and cameras, I'm talking about that, on the shoes. And it can check for gait and things like that. So there's one I shared recently. So think of it as your body. And the medical equipments could be a pacifier, things inside your body or on your body, right? So that is the first set of devices. Then you go out from there and say, okay, my home environment, or it could be a work environment, right? So we have, offices which have automated buildings with all kinds of energy equipments being monitored using AI, and they're all digitized and IoT, right? Or it could be security cameras like you were talking, or it could be home automation devices, or it could be Alexa or Google Home and things like that, right? So that's in your home, right? Or even in your garden. A lot of things. I just looked this side and I remembered my garden has a whole bunch of IoT that turns on and off at different times, and what is my plants, and all that is possible because of IoT, right? Then the next level is you get out of the house into the road, and then the car and the trucks and all kinds of mobility devices or sidewalk robots. And a newer one these days is not just a robot or autonomous vehicle. It's called autonomous mobility robot, or AMRs or AMV. And sorry, I have a bunch of devices that are all sending me notification. I'll just make sure that they are closed mute for the next hour. Okay, so our body, then then our home, then then the road. So it's not just the cars. I mean, I'm obsessed with autonomous vehicles and self-driving cars, and I chase them. And I swear I see them every single day. It's not the Waymo is now like giving us robot taxi, but there's all these homegrown ones that I see all around me almost on a daily basis here in Silicon Valley. And then it could be the camera. The other cameras we missed is city cameras, right? The traffic cameras. So the city, all the sensors checking the weather in the city, or the cameras watching us on the road, or traffic lights, and all of those are also city ones, right? And then you go to the factory. So then you go to equipments in the factory, and Dr. Karsten is going to say more about it than me. So I'm going to hold off on the examples. So that's the way to think about edge devices. Now coming back, edge AI is AI running on the edge of any of these devices. Edge is the industry jargon terminologies for those of you who are not in this space. Basically, AI running on a device instead of AI running on a cloud. And it could be a combination of AI running on the device and the cloud, or sending information to the cloud. That happens in a car. It sends data from the cloud. So, but the idea of edge AI is when AI is built somewhere and runs in production or inference, it takes in data, and it makes a decision. Finally, all AI is trained by data, and it runs on data, it spits out data. That's the only language it understands. To do that, it takes data from the sensor. So it is more than just like a Google search or something that is a piece of software. The Edge AI brings our environment, it senses the environment, uses the sensors, uses that data, feeds it to the AI, and then the AI does what it's supposed to do. And I'm going to, I see a question or comment here. Traffic lights, here we have traffic lights attached. We take photos of traffic violation. Yes. So that has become a common use case, Yash. And I had shared a while back, I think this was tested out in Sydney some years back, where at the traffic light, when the camera is able to see a person, they try to use computer vision to see, is the person on the driver's side? I think that driver's side is the other side here. So they sit on the driver's side or the passenger side, and did they have a phone? And then they would send a ticket if the person is on the driver's side and they seem to be fidgeting with the phone. And they tested that out. I do not believe they made this into production. Any guesses why? Deepika, this is right in your realm as my AI ethics program manager. Why do you think they did not implement this live and make it into production? So the important thing is, there are beautiful use cases. You can think of what is possible just because you have access to, a camera giving us data, and an AI being able to run inference and make predictions from it. But then you have to see whether, do you have access to the data? Is that a privacy violation? Not because it is compliance and law, because that's the right thing to do. Do you want to be snooped around, and is that something that you would like? Then don't do it. And so when you think about building that I think that's important. Okay, Deepika is saying she wants to hear from the experts, but she has actually come up with AI ethics use cases, and even we have like AI ethics demo this time in my AGI course. I'm not going to share anything about the AGI course because Yash has done a beautiful explanation of what is AGI. So with that, I'm going to pass it on to Karsten. Let me bring Karsten back. Karsten, welcome back. Karsten is an amazing entrepreneur and innovator, engineer from Germany. And I already told you how excited I was the last time Karsten was here. And I'm blown away by what his team has got done this time. And for those of you who are regulars on WeeklyWed, you must be registered on WeeklyWed. But this time in the WeeklyWed registration, bit.ly/WeeklyWed registration, we just added a link so you could download Karsten's team's white paper on today's topic. You don't need to register. We are not interested in catching your email or do anything. We just want to distribute Karsten's white paper, so do get it, and I will add it in the stream comment, and I will add it in Business School of AI on LinkedIn, so you can follow up and get all the goodies from today. So with that, I'm going to pass it on to Karsten. Karsten, thank you for joining us. Give us a more holistic intro to yourself, because I just know every time you show up with an innovation, that's what I know. Last time it was audio-based innovation. This time it's computer vision-based innovation. But I love that you are focused on the factories and not just like, yes, I'm innovative and my team is amazing and we build interesting things, but to practically go solve real problems for industry. I just love that about you and how you can operationalize that. So with that, I'm going to pass it on to Karsten, and I'm going to get off camera. Take it away, Karsten. Thank you.
Thank you very much, Sudha, for the introduction. I hope you can all hear me okay.
Yes.
My name is Karsten. I'm Managing Director of Synfozy and Mobile Vision Technology. Mobile Vision Technology was founded together with Alex. Alex is also in the call today. To my background, I'm originally a chemist, and but then I started in manufacturing consulting, shop floor consulting. After my studies, I worked with some of the well-known manufacturing companies in Europe. I did that for 10 years. Then I built software companies for 10 years, sold them, one to Palo Alto and one to Bosch, where at Bosch I became vice president for all IoT applications worldwide from 2010 to 2015, where I also met Rob. Hi, Rob. And we invited him to one of the business IoT. That time it was IoTS when Bosch started, and afterwards it was just IoT. They skipped the S for what was standing for service. But I left Bosch in 2015 because Bosch is too big for me and I'm more kind of an entrepreneur. So I founded my 5th company, what was Synfosy. And that is what Sudha was talking about. It is you're taking your mobile device as a fitness tracker for production. This is how you can describe it in practical. So we record sensors from the mobile, things like acceleration, things like light, things like magnetic field, and we utilize also the cameras since we have mobile vision technology. With this, we have 170 customers in 15 countries, from Japan to North America, Mexico, once around the globe. Well, that are very excited working with our solutions because they need data from the production floor in respect to machine information. So how long the machine is running, how many stops it has, when the stops occurred, why the stops occurred. We can even do predictive maintenance directly on the mobile device. This is the one side, and we have the other side, what is logistics information. It's tracking. Originally, it was just beacons, iBeacons, and we have been for a long time the only company worldwide that did reliable localization with iBeacons. But nowadays, and this I will show you a bit later, we do it also with QR codes now, with one photo, and we get 3D data, what is really, really, really cool. So let me share my screen and I have a presentation for you. Surprise. Let's see, eingeben. This one. Maybe. No. I hope you see it.
Yes.
That's good. Let me try to now. So put the in here. There's a 5. I don't know why it doesn't work. Now it works. And again, I'm super excited to be here in Sudha's course because it's very interesting always to hear about the topics I usually can't join, but mostly I look it up then in YouTube. So we founded mobile vision technology in 2024, mid of 2024. Why? We have customers in the wood processing industry that have an issue, and the issue is they cut wooden planks to get furniture parts, and they staple it with a robot, but then they have to put it back to the machine, and this is done worldwide by people. And this is not a good process because this almost completely automated factory could do 35% more productivity if a vision system could see the parts and tell the robot what to take. And this was where we started. And today we are in the position that we have the only viable and fast solution that takes parts from a pallet and puts it to the machine with a precision of a millimeter or better. But we did many, many more things in 2024, and I will show you some of the things. Why do we use or why we have issues with vision systems and why we are working on this? Usually you have bulky industry cameras, and you see them here on the ceiling of this machine. There are 2 Keans for 4 lenses cameras, each of them 40K, so quite expensive. Then you need special lighting and an environment, and you need separate computing and software. And usually, as Sudha said, this happens on a server. So you have NVIDIA servers to get the parts and know what it sees. So this is a pretty much complex environment. And one of our customers said, you are using these nice little devices, and there are so many sensors. There's also one more sensor. It's called camera. maybe we can use this to make these plates and unstaple them and bring them to the machine. So yes, we said maybe we find a solution that is not that expensive, not so inflexible and hard to scale like the industrial vision systems today, because you hardly get any vision system below €250,000 or dollars. So this is pretty much expensive. If you think what such a mobile costs, even it's if I have the S25 Ultra here, I have 5 cameras, and only the cameras, if you could buy them from Keyence or Cognex, what are the leaders in vision systems, you would pay more than $100,000 just for the cameras, not thinking about the computing units. So we built the first truly integrated edge vision system. In fact, we didn't build it, we use it, and it's a smartphone. We're utilizing cameras from the smartphone, and we are also using the processing power of such a smartphone. So we have one edge device, and this is all in one. And if you have that, you can think of so many more applications than before, because you don't have these bulky cameras. You don't get into every position, and it can be mobile, it can be static, and there's a lot of possibilities I will show you in the next following slides. So what's the advantage of such an edge device? If you don't have to transfer data from an edge device, you are much faster. Now, if you can compute directly on the device, it is real time. The plug and play is in minutes. Finally, it's running an app on a device. Yeah, there's more I will tell you, but finally it's an app. And if you look what these cameras can do today, they can do micrometer accuracy. So this is really important and really, something you cannot achieve with these more, I would say, low value industry cameras you get today. So you get up to 95% cost savings, because at least you take the cameras and the computing unit out of the equation. What makes it ultimately affordable also to be used by small and medium-sized enterprises. As I said, this was the first customer we had. We built this because Burger, this company here, asked for it. So they said, we need robot vision for planks, pixel precision 1 millimeter or better. And we recognize now all edges, and we find all these planks, and we find invalid planks. So the robot knows which plank to take, because we also have the center of the plank, and we have all information in one glance of one picture directly on the edge. This is something that brings up to 35% productivity in an almost automated, fully automated industry environment. So maybe you don't know, but if you have standard furniture companies like Burger, they're building kitchens. From 100,000 parts, they build 1,000 kitchens per day with lot size 1. There is almost no person. There's almost everything done with robots, beside putting the planks back to the machine. So this is an industry, it's already an industry leader, but with this solution, they come on the edge at very much more. We are doing also other things. We are working with WashTag to make your wash portal analyze your car after it has been washed. So it will find issues with tires, new dents, known dents, and new scratches, just by analyzing your car with mobile devices built into the site. So when the portal runs over your car, it shows what it sees. Sorry. There are many, many more examples. Something we will start now with EWM and First Alpine is a process worldwide that is done by people. It's the quality of welding. So in shipyards, in pipeline, wherever you have a lot of issues with welding due to much current, much power, too few power, whatever, wrong material, where you can see a lot and some you can't see. But everything you can see, you can analyze and digitize with your mobile. and directly build an AI reporter out of it. The potential of savings for this, because I think something like 6 million kilometers per year is welded, something like this is a figure. You can save 3 to 30 euro per meter of welding. So this is a potential of several billion euro savings per year just by applying Edge AI to the device. So what we do usually, and here you can see it, we have two things. What we do, we train models like you do for LLMs. So for ChatGPT also, there are also LLMs, but we do it for pictures and annotate them. And we are doing something that is more rule-based with something like, for example, OpenCV, what says, okay, an edge looks like this, and if this is an edge, and within this edge we find an issue like down here, then you have to take a photo or make a video and put it to the report. So these are the things we do directly on the mobile. Another thing, as I said, our mobiles already collect machine data by analyzing the vibration patterns, the movement patterns, or analyzing light signals, or analyzing magnetic field. When you put the mobile on top of a current running cable, you can measure how much power is run through. But nowadays we also do many more things. We utilize the cameras to do something very simple. It's called OCR. So you put the camera on top of the machine, of the HMI of the machine, and say, okay, I need this part and this part and this part, and it should be written to the database. And so we digitize legacy machines within 10 minutes without any issues. Some examples here in the chemical industry or in the plastics industry, where they have really old machines, because a machine is not like a car removed from the factory after 3, 5, or 8 years. It runs for 30, 40, 50 years at least to get back the money. And the HMI usually runs, or we have HMIs running still on Windows 7. So it's something old. And then we only have a screen and we get the data from the screen. But now this is the coolest thing, I think, BMW said this is the coolest thing since the invention of the wheel. We do now precise tracking of factory inventory. For this, we also utilize the camera and the edge capabilities of such a mobile device. And we built with this the most precise and most affordable real-time location system. RTLS is real-time location system, asset tracking system worldwide. You may know or may not know that today, real-time location system is done either by RFID, what you may know, by ultra wideband. This is the most expensive thing. A tracker like this costs 100 euro plus, and with Bluetooth, what we do. But now we print the trackers. So this means we take completely out of the equation the hardware for the signal giving, because the signal giving is simply a QR code. And with this QR code, seen in a mobile device, and when we know where this position is within the factory layout, we know where this asset is within the factory. It's so easy. And we can show up to more than 100 different QR codes within a picture. This is easy with a mobile device, and we only transfer X, Y, Z, because we encode into the QR code the size of the QR code. And when we know the size of the QR code, we can measure the distance from the mobile to the QR code. This means we know the Z. We know X and Y within the mobile device. And when we know where the mobile is within the factory, we know X, Y, Z within the factory of each and every device that has been tagged. So as we use mobile devices and we don't use the most expensive one, we use something like Xcover 7. This is something like this here. You see in your screen. This is a ruggedized military standard mobile from Samsung. and it has a lot of advantages. You can operate it underwater, and definitely it's fine enough to be operated in a factory, and we have them since a long time in the factory. And what it gives you is, and you can see it really good because it's here, it gives you the positions of all the assets within your factory, and you can search for single items, and it shows it to you. Some of the customers have been listed down here: BMW, DAXA, and Schwarz Gruppe. Schwarz is the biggest retailer in Europe, with a lot of brands. Maybe you know them from Schwarz Digits. They recently announced that they built Europe's biggest data center, just like 60 kilometers from here, in Brandenburg, for 30 billion plus euros. So it's a pretty big one. And yeah, it's something that competes with some other operating system or data centers in Europe. But they recently announced the biggest one for Europe. So what we can achieve with such a system is sub-millimeter precision. And today, in comparison with ultra-wideband, you can get, if you are good, 30 centimeters precision. But it's not a 100% value, it's a 95% value. We achieve sub-millimeter precision with 100% value. Why? Because all the radio signal-based systems like ultra-wideband, Bluetooth, and RFID are based on radio signals, and they are not stable. They are reflected and absorbed by metal and water and whatever. This means the precision is never 100% and cannot be, just by design. But with a vision system based on light, yeah, we get really sub-millimeter precision with standard smartphones. We do optical tracking with Edge AI. What does it mean? We don't only recognize the QR code, we do a lot of calculation on it. We do pose estimation, so how it is rotated in the picture according to the mobile. We do 3D data in one step, as I said, so we get X, Y, and Z. That you usually never get unless with radio-based systems, unless you have a lot of antennas, something like 6 you need, and we do it with one picture. And it's 100% GDPR compliant. Why? Because no pictures are transferred to any server. The pictures stay within the mobile, and we compute them on the mobile. We just get X, Y, Z, we get the tracker ID, and we get the timestamp. And just these data plus the device ID goes back to the server. This means a very, very small amount of data is only delivered to the server. So very, very small one. And this is good for the company and bad for NVIDIA, because usually, and if you have seen here, DAXA has developed a solution with NVIDIA that transfers, it has industrial cameras, and the industrial cameras send periodically pictures to the server where they are stored, and then NVIDIA, CPUs, GPUs crush the data and determine the position. But just they only have X, Y, and they don't do Z. And I don't know why, but they only get 50 centimeters precision. We are much better and much faster doing it on the edge. So why customers do that? Usually you have bookings in the factory. You need to know at which part of the chain your material is located, and you now have no more bookings and no more issues because the person is scanning the wrong part. There is almost no more manual scanning needed, and you have more safety and efficiency. Example calculation for a customer: 65,000 square meters, 1,000 assets, less than 40,000 euro annually. We have similar we have seen similar installations with ultra wideband. Then you have an installation price of something like, in this area, 1 million at least, and more than 150 to 200,000 euros annually in costs. This means with 65,000 square meters and 1,000 assets, this is ridiculous low, but it's simply by design. As I said, we have been trusted since May 24. Some of the customers are on this, some are not. So we have a lot of customers in production. Most of them are in production, to be honest. But we are also discussing in the moment with detection of cows in the stall. Why? Because if you track your cows and you know how they usually move and how they now move, then you can predict if they are ill or not. First, it's like with people, if you are ill, you move differently as if you are healthy. And it's the same with cows. We tried it 4 years ago with beacons, so with these ones, but it didn't work because the precision was not there. Now we have a much higher precision and we can do this on the edge. And this is a lot of advantages we can bring now to all farmers worldwide. Very interesting. A few voices on our system from Schuler Consulting, was the digital consultancy of Dürr Group. It's a big industrial machine manufacturer. They said we are set to revolutionize the wood processing market. That's Bastian Schulz, head of smart manufacturing. This is one of our customers. He really had an issue with all these different furniture parts, with glossy and with matte and with different structure and black and white and different blacks and gray and so on. Now all this is solved because we trained the models, and it's now running on the edge. And also for journalists that really like the idea of edge AI, what we have in our DNA 100%. It's really a great thing what you can do there. So what we are doing, we are unlocking new capabilities in the whole industry. Because with that, what we do, we can work in areas where you cannot work with normal vision systems. We can see things that only humans can see. Maybe one example, this camera, the best camera of the S25 Ultra, has 200 megapixel. The retina of your eye has 500 megapixel. But Samsung already announced that within the next 2 years, they will have a 500 megapixel camera on the mobile phones. What this means is your eye is not any more better than a camera from a mobile device. And this is not the end. The eye won't become more precise in the future. The technology that is built, I'm pretty sure that within one decade or so, we will be at 1 gigapixel, something like this. And then you exceed the possibilities of humans by far. You also see this with LLMs. They are working on super intelligence, what means they want to be better than humans in thinking. And all this now plays together. Very interesting times. Yeah, we can implement the unexpected. Nobody could think that a wash portal can inspect your car, or that welding could be analyzed differently than by humans. There are so many unlimited possibilities we see, and we are asked from companies. Yeah, one company from the Schwarz Group asked us if we can do supervise if someone is parking in the wrong spot. Sure, we can do that when we have the position of the smartphone and we mount it on some car or some garbage truck or whatever. We can easily do in the same time when the truck or the car runs, analyze the side of the street. We are currently doing something with the airport of BER of Berlin. We are tracking people, but not by face recognition, just by this is not allowed in Europe, but just by features. So it's a person with a blue jacket, a yellow hat, and a green shoes, something like this. So we can track him through the whole airport and tell them how the people are flowing if they go to their gate. This is very important to optimize the airport logistics. Yeah, and the costs are so much down compared to all the different systems, because vision systems, because we have everything on the edge, what is really cool, but also gives us sometimes real headaches to optimize the code that we can still process these complex pictures we see. The team behind the vision is Alex. She's also CEO, my co-CEO. She's doing marketing, social go-to-market. She writes posts in LinkedIn with up to 1.5 million views, what is really cool. I never thought someone could do that, because my posts usually stop at 1,000 or so. Yeah, it's me, former Bosch vice president and consultant, tech founder. We have Dennis, double PhD for physics and mathematics. He's really, really cool. And he's the brain on the development side. We have Mariam, she's head of AI. She's from Iran. She's 10 years in vision and AI. And we have a couple of developers and working students driving the innovation forward. This is mobile vision technology. So if you have any idea where we can impact your industry, let's discuss this and see if we can do something in the industry together. Just contact us via the website, via email, via Sudha, via Rob, and others. It's easy. We are already pretty much known. And thank you very much for the invite, Sudha. And I'm opening the discussion now.
Can you stop the share so we can see your face, if you don't mind?
Sure.
Thank you. I want to bring Deepika online. Deepika, if you want to come on camera, it's okay, or you can just field questions. She's our host usually, but I just wanted to give you enough time, so I didn't even take time to introduce Deepika. So,
hello, everyone.
Yes. Any questions?
We do have a question from Sudha, actually. Cows wear pedometers. Can't that data offer insight using gait data on a broader level? I'm curious when you use audio data versus when you use vision data.
Yes, there's a lot of different approaches how to track health or maternity or stuff like this with cows. I know that. So some put something into the cow, some electronics, and get the data out of there. And it is possible to a certain extent to get information. But if you are looking to social interaction between cows or something, you need to know where the cows are. Maybe there is a coexistence between these two types of data. You see what cows are doing, where they are, and you see what kind of other data they produce, like you can measure heartbeat and other things. But if you want to see if they are lame because they have something with their legs or so, you don't see that usually from the other data. Therefore, we are working with this FBN in Dummersdorf, what is a research facility for health of cattle. And yeah, they say if you can supervise the cows and see if they have issues, you can save per cow per year 1,500 euro for the veterinary. And yeah, and you see that the cow dies before it dies. That is very important.
I want to ask an add-on question. I was thinking about this more broadly, because you use audio and you have a bunch of different use cases, and sometimes now you have an amazing set of use cases with video. So when do you use audio data and when do you use video data, or do you use like a sensor fusion with a combination of these? Is it even possible?
Yeah, usually we don't really use the audio. We use the vibration, but it's not audio directly. Why not audio? We worked with audio in the beginning, but it's not it does not give you real good results. Why? A forklift truck is running by, someone is talking, and so you get a lot of noise that you have to filter out by some means, and this is not easy to do. So this means we take the vibration, so we really mount it on the machine, the mobile, with duct tape, for example. Yeah, in the beginning, afterwards we screw it somehow there. But in the very first, when we go there, we take the mobile, duct tape, zack, done. It's mounted, yeah, and we don't even need any screws. We don't need even power because we have a battery, and we don't need Wi-Fi because we have GSM, and we don't need the IT. And every machine is live in 3 minutes. Yeah, and we use the acceleration because as I said, the microphone gives you a lot of signals, but a lot of false signals. The vibration of the body of a machine is always the same. Yeah, and nobody is interested if someone stamps on the floor beside it. The machine weighs 10 tons, and the person weighs 100 kilos, so it's not of interest.
Yeah. And is there a specific set of use cases? How do you look for using vision, right? Is there like a certain parameters where you say, oh, because you have innovative products in every possible data source?
Yeah. I can tell you how I came to this vision use case for the cars, for the inspection of the cars. We have been at CES last year. We will be at CES this year as well. And last year, Amazon came to us and they said, we have more than 100,000 trucks. We need to inspect them. And we do that today with people. And we see here, you can do it with a mobile. It's still not happened, this project. But we then went to WashTag, what is the European or worldwide leader even for wash bottles. They are also present in the United States under a different brand, doesn't matter. And they're interested in that. Yeah. So we started with them, unless finally Amazon is only a customer for us. Another use case with the welding, I have been at a tour in Vietnam this year, a business tour, and I met the CTO of EWM, what is the worldwide leader in technology for welding. And he said, we have welding processes, and we do it today by inspection of people. Is there another possibility to do that? The answer is yes. Simple. Yeah, it's simply yes. It's not complex. It's it's not that easy because the issues can be very broad. But the issues with welding are the best documented issues worldwide. There are thousands and thousands and thousands of pictures, what means we can easily train a lot of very good examples and train the AI to detect exactly if there are spatters or there is a curve or whatever from predetermined pictures. So this is pretty cool. So someone came to us. So usually it develops in a discussion. Yeah. But there are so many more possibilities. You can inspect house walls for issues. It's so broad. Everything you can see as a person, the AI and the edge device can do faster and better. It's like this. Yeah.
Thank you for that. Renee also has another question. Since your systems are cost effective, have you deployed it also in very small companies, for example, businesses with less than 20 employees?
Yeah. When the use case is covered already, yes, this is easy because it's not expensive. We are currently working on an open source platform where you can build your own processes exactly for this purpose. So you say, I need to take a photo first, then I need to make it blur, and then I need to remove colors for black and white, and then I have to do whatever stuff, and then I have to run AI on it. This is under development, will take another year. It's not so easy, but eventually you will have that, and you can build your own processes and then run it on the edge, or you can take predefined. We will also have a store where people can put all the recipes, I would call it, the processes. Yeah, so this is, yeah. It doesn't matter. The size of the company doesn't matter. The solutions are, finally, it's an app. Yeah, so you can take it from the App Store and just put it on your on
Right.
your device.
Yeah, I mean, I guess when you're talking about like before, when we were talking about pedometers on, cows on a farm or something, it really doesn't matter the size of the farm if we're dealing with the same
No.
source of data in that sense. And then one of the final questions we have, isn't it a challenge to get lots of data for vision from Sudha?
Yeah. When you have this mobile, you can press picture, 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 and then you have a lot of pictures.
Yeah,
We even do it automatically in the moment.
right.
We have a detection if something changed in the picture, and then we take a picture. So it's automated. So it's just you just put it on the robot, and it continuously takes all the pictures you need directly with the mobile at the place where it is with the lighting conditions that will be there.
I
Yeah.
see.
So for this, yeah, no, it's not complex to get these pictures. You can get them from a lot of sources. Sometimes, as with welding, there are databases with pictures. In other cases, you can simply make them. Yeah. And you can retrain, and this is also what the LLMs do. They train more and more data into it. It's not the end. When you have one model deployed, you can further train it. So it's a growing database and
Right.
growing
So there's
model.
room for error, is what you're saying. Yeah.
Yes, correct.
Mm-hmm. All right. Well, does anyone have any more questions?
No, just thank you, Karsten. And finally, I'm happy to see it. Congratulations. It's yeah, it's a magnificent vision, like a way of seeing that can come that is becoming real because of the capabilities on the edge and the AI. But you um, you need to have this. You need to have the idea, and you need to have to make it real. So
Yeah.
that's not an easy thing to do, and the opportunities seem endless in this. So congratulations, and yeah, we stay in touch,
Yes.
and if there's anything I can do, please let me know. And thank you, Sudha, also for hosting,
you.
and yeah, Devika for your moderation. And yeah, I'm gonna grab something to eat now because otherwise I'm fainting. But so
Thank you
thanks
so much.
again, and yeah, talk soon. Bye.
Thanks, Rob.
Bye.
Thank you. Bye.
Thanks for being
Bye.
there.
Bye.
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 Thank
Bye.
you.
Before we close out, I just wanted to remind people our next week, we're doing WeeklyWed every other week, and middle of the week is combined with Sudha Live, where I do a live and take questions from my learners. So the next Sudha Live is on December 17th, and since it's closer to the holidays, we have a holiday learning plan. So I'm just putting the link in here. So sign up, and I will see you guys there. And thank you, Deepika. Thank you, Karsten. Elam will be
Thank you very
following
much.
up. Elam will be following up, and Alex, we're happy to work with you to send clips out to your brilliant network. That's amazing. Elam, can you connect back here with Alexandra right here? She's here, but I can connect you guys on email also.
Yeah.
Thank you so much, Carson.
Thank you, everyone.
Okay.
Thank you
Thanks.
very much for the invitation, Sudha. It was a real pleasure and was fun.
Thank you
Yeah.
so much.
So
So
fun.
if you're
Thank
new
you.
here, join the WeeklyWed bit.ly/WeeklyWed registration, or just come to Business School of AI on LinkedIn. That's my learner community where we will share all the links and the next event and little clips from here.
And you can rewatch this on the YouTube page.
Yes.
So if you have questions for Karsten, you can follow up with us and we can pass it Karsten's way.
Yes.
Thank you so much, everyone.
Okay. Bye.
Sudha, Devika,
Bye.
thank you very much.